Hello everyone, Mr. Hisner here, and today we are going to be working with rectangles. What's the deal with rectangles? So, rectangles, what we find are what you may assume to be a simple shape, but I think in reality you'll see that these are also parallelograms, which I know we all enjoyed so much of. So, with that said, let's just jump into it and see rectangles. Rectangles have all the properties of parallelograms. So, opposite sides are parallel and congruent. We know that opposite angles are congruent. We know that diagonals make a midpoint. And we know that the consecutive interior angles are supplementary. Plus 2, right? The strength of 10 Grinches plus 2. So here's our plus 2. Rectangles, all four angles are right angles. Also, diagonals are congruent. So the diagonals are the same measure. Okay, what do we got here? So we're given, let's just check this one. We're given PQ, we want to know QR, we're given this one, we're given this one. We want to know QR, well, that's going to be 10. We want to know SR, well, that one's going to be a 24. Nothing to it yet. We want to know SQ. Wait a second. So this is something that you've all learned in middle school. So here we have a triangle. This piece is 10. This piece is 24, and we want to find this piece. We don't know what this piece is. We can use the Pythagorean theorem, A, B, C. The hypotenuse, the longest part of the triangle, the hypotenuse, don't try to play me, I know you all know this. The hypotenuse is always C. It's always C. So 10, we have the Pythagorean theorem. A squared plus B squared is equal to C squared. So 10 squared plus 24 squared is equal to C squared. We do this computation and we find this to be 676, and this is equal to C squared. I'm just not going to put X here. Now, this measurement isn't 676. That's too long. It's too long. How do we get rid of the square? Well, we square root. Squares and square roots cancel out. So the answer to this question is actually the square root of 676, which we find to be 26. And so our measure here is 26. That's what SQ is. And SQ is a diagonal. And guess what else is a diagonal? PR. So PR then is also 26 because, like we saw up above, the diagonals are the same measure. And finally, we have QT, which is half of our diagonal, which we found to be 26. So half of 26 is 13. Again, A squared plus B squared is equal to C squared. C is always the, what's it called? Hypotenuse. C squared is always the hypotenuse. Okay, so now that we have that out of the way, which one do we want to look at next? Let's look at some angles. Let's look at this one here. So we have one thing that concerns me is that some of us don't know what angle WXY is, and that means that you haven't been paying attention since the first week of school or second week of school, which for me is actually pretty concerning. So now is the time to really, just try to learn how to find these angles. Actually, you know what? This is not how I do this. How we do this is we find all the angles first. So I know these two angles add up to 180 because they are a linear pair. Again, this is the third or fourth week of school, that stuff that we're learning here. So This is just things we have to know. So 7 minus 6, this is 116. So this one in here is 116. This is a vertical angle, so this is 116. And this is also a vertical angle, so this is 64. That is how we do it. Now, I know that these two angles this angle is 90, right? And this angle is 90, but I also know that these two angles will be the same. How I know that is because, well, these diagonals are congruent. And so that means that this is an isosceles triangle. So those two angles will be the same. And so I know that 64 plus some value, let's call it x, plus the same value is going to be equal to 180. X plus x is 2x. I can subtract 64 from both sides. And so this is going to be 2x is equal to 116. 116 divided by 2 is going to be, let's see, 50 plus 8. This is 58. And so that means that this angle down here is 58 and 58. And notice that we have alternate interior angles, right? So these are also going to be 58. And now we need to find these other angles in here, and we can use the same computation. So we have 116 plus some unknown value, and the same one is equal to 180. So this is going to be 2x is equal to 64. 64 divided by 2, this is going to be 32. Or likewise, we know that this angle up here is 90 minus 58. That will give us our remaining angle 32. So either way you eat the Reese's, there's really no wrong way to eat a Reese's. And here we have all our values. So let's go through and see what we have. So we have x, w, y, x, w, y. So that one is 58, found that one. We have y, x, z, y, x, z. That's 32. Found that one. And again, for those of us who don't know what this is, like this is honestly a genuine concern of me, for me. I'm concerned not only for your grade at this point, but also like mentally, where are you when we're learning this material? And again, this is something that we did. We literally did this the second week of class. This is something that we've been doing for 4 months. If we can't remember stuff for 4 months of being taught it, at a certain point we need to look in the mirror and ask ourselves, why am I not getting this? Is this a problem that I'm having in this course, like between me and the material? Because Mr. Hissner just keeps teaching it, and it's just not sinking into my face brain. So let's see, W, Z, V. W, Z, V. Oh, that's when this in here, that's 32. X, W, Z, X. W, Z. Oh, of course, that one's going to be 90 because that is a big angle. Oh no, this was the wrong one. I did the wrong one for this one. X, Z, V. That's this. X, no. W, Z, V. I can't read. W, Z, V. W, Z, V. That's 116. That's on that inside there. 116. And then we have X, Z, Y, X, Z, Y, X, Z, Y. There we go. Another 58. So again, I know you don't have this, but you got this thing. You got all 5 of these, right? Even if you had 4, you might be able to pull it off. So what I suggest you guys do is go ahead and draw a rectangle. I know this is weird, but if you just had a piece of paper, all you have to do is just do something like this. And you don't got to be Picasso with it. I'm not Mr. Peffer. I'm not going to grade you on your drawing. But really, all you have to do is draw this, right? These two are the same. 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 This is a linear pair. These ones are the same. These ones are the same. And finally, these ones are the same. So, I mean, no big deal. Again, something that we've been doing pretty consistently every week and since the first or second week of class, minus the similarity lesson that we had right before the break. So again, at a certain point, like if you're not getting this, you need to make some adjustment in, maybe the way you're taking notes, maybe the effort you're putting into your homework, just the overall attitude you have maybe towards this class and we're learning the material, maybe watching the video lessons. I know only about half of the class watches the video lessons. So If you're stuck here, well, then you're not watching this, right? Am I right? All right, so I'll stop preaching to you guys. Thanks for watching.